January 17, 1994, 4:30 a.m. A giant 6.7 magnitude earthquake rumbles through Los Angeles. The shaking awakes residents. They discover that power had gone out citywide. Some leave their houses or peer outside to check on the neighborhood. It is eerily dark.
January 17,
No
1994,
traffic
4:30 a.m.
lights, no street lights, few cars at that late hour. They look up in the sky. It is flush with cosmic bodies that had been invisible up to that point. Twinkling stars, clustered galaxies, distant planets, even a satellite or two. Then some people become nervous. What is that large silvery cloud that trails over the city? It looks so sinister, they call 911. That cloud was the Milky Way. They had never seen it before. Hello and welcome to the Birla Industrial and Technological Museum's online lecture celebrating the wonders of the night sky with an everyday guide to making them our own. After all, the sky is inherently democratic. It's accessible, in principle anyway, by anyone everywhere, just simply by the act of looking up. In the last few years, there has been a surge of beautiful night sky images popping up all over the web. In a day and age when many of us live in large cities and most people have never seen the Milky Way, these photos bring to life a part of the world that has nearly been lost. They make us look twice and wonder, how do they do it? For today, we hope to discover the answer to this very question. We'll be looking forward to your comments in the chat box, which will be open to receive your queries. We'll try to take them up at the end of the session. To delve into the nuances of everyday astrophotography, we have with us a very special guest. I would request Director BITM, Mr. V.S. Ramachandran, to introduce us to him and initiate this masterclass in capturing the heavens. Over to you, sir.
Thank you, Aditi. Good afternoon and a warm welcome to BITM's online lecture commemorating the Science Week, which is going on now. In fact, if you visit Birla Industrial and Technological Museum, you can see a special exhibition, 75 years of Indian journey through science and technology. Sharing with us his tried and tested techniques of everyday astrophotography, we are delighted to have with us today Dr. Arup Dutta, Director Nephrology and Transplantation, Fortis Hospital and Kidney Institute, Kolkata. A warm welcome, sir. In spite of your extremely busy schedule, I am very happy that you are with us to give a talk. A fellow of the Royal College of Physicians, London, he has 30 years of experience as a practicing nephrologist, being one of the first in Eastern India to have obtained structured training in the subject. An early adapter of new technology and therapeutic causes. Dr. Dutta is also an astrophotographer. He is also a strong enthusiast of astronomy. His quest for perfect annular eclipse, or perhaps the most appropriate location for spotting the northern lights, has taken him far and wide. Yet, close to home, he remains ever eager to communicate the science that guides his voyages and enables his magnificent front page worthy captures. A close associate and a very dear friend of BITM, we welcome you, sir, to deliver the talk Wonders of the Night Sky, an everyday guide to capturing the heavens. The forum is open to you, sir. Welcome.
Thank you, Mr. Ramachandran. Thank you, Aditi, for putting this all together. So I'm extremely delighted today to come back to BITM after maybe several decades. I have a very long association with to come here during our school days and later also. And I'm very much delighted to speak about the things I like, that is astronomy and photography, and from the premises of the BITM, where I've come back maybe after 40 years or so. So let me share the slides. Yes. So, the the main purpose of the talk is to explain the use of simple equipments and the techniques to capture the night sky, and also how to understand the celestial events. Now, you see the picture of the Milky Way. This is what Aditi was referring to when he told you about the story of Los Angeles on that evening when the earthquake happened and people got afraid. They thought that it was a spaceship. It actually looks like that. And people started calling 9/11. My own experience with the Milky Way was no less overwhelming. Actually, we were traveling in the Yellowstone National Park, and I had convinced my son to take me back into the park in the dead of the night because I wanted to shoot some star trails. We were not prepared for this sight, and when we got down from the car, actually there was the headlight, so we thought that there were stars in the sky, but we didn't understand that the Milky Way was also there. So we got down from the car, and it was an amazing sight to the point of being overwhelming. So that all four of us, my wife, my son, and my daughter, we all let out a gasp of disbelief. It was just there staring at us from one side, from one horizon to going up in the sky and getting onto the other side of the sky and down to the other side to the horizon again. What the bright spot you see here is a Milky Way core. And just for the sense of scale, let me tell you that that's 25,000 light years away. And again, what is 25,000 light years? The sun is 8 light minutes, and the moon is about 1.3 light seconds away. So you can understand how big the universe is. So this brings me to this wonderful quotation. This is a very old Persian proverb. Night hides the world, but reveals the universe. Now, if you're interested in the night sky, you will be able to see a lot of things, and you'll be able to photograph practically all of them. So what are those? You have the stars and the constellations, you have the star trails, the Milky Way, the Aurora Borealis, you have the lunar eclipse, the solar and the lunar halos, you have planets, and you can also take nightscapes in moonlight. We can also photograph the solar eclipse and the sunspots. They are shown in orange on the side because that is not nighttime. It is not essentially night photography, it's daytime photography. But to catch the sun, you have to use a solar filter, which turns the sky absolutely black, and it gives a little orangish tint to the sun. I will be describing these techniques one by one, and three major sites which I feel that these are the best sites that you can ever have are the star trail. The star trail is, of course, you don't see it, you have to imagine that. The stars constellation, the Milky Way, Aurora, and the solar eclipse. These are the real fantastic sites, and I'll take you through each of these. So what is the equipment that is necessary for astrophotography? As soon as you say astrophotography, what crosses your mind is a big equipment setup. You have telescopes, you have attached cameras, but those are really necessary for the deep sky images. And you have trackers, because the telescopes have a very narrow field of view, and it will not remain focused on your thing because the Earth is moving. So in order for the telescope to remain fixed to your object, you must have an equatorial mount, is also called trackers, which compensate for the Earth's rotation. It moves the other way around, and so that your telescope is focused onto the star or the object that you're trying to image. Now, that really sounds quite sophisticated, but all I'm here to tell you that by your usual DSLR and even your compact camera, of course, you have to use your compact camera in the manual mode. The auto mode will not give you anything, but your standard DSLR, using a variety of lenses and even your compact camera, you can catch practically everything that I'm going to describe here. All my photographs have been taken by these three. About 40% have been taken by compact cameras. Now, the smartphone cameras are increasingly getting smarter, and many of them are now coming with a night and a star mode. And in probably 5 years' time, you'll be able to photograph the Milky Way and the Aurora Borealis and the constellation easily with your smartphone. Now, processing in RAW is always better, but RAW also means a lot of work and a lot of space. JPEG is what most of us take, and I have no hesitation in telling you that most of my work is on JPEG because I don't find time to go into all that. But of course, if you can do it in RAW, that is obviously the best. For processing, you can have the Lightroom, the Photoshop, and the Star Stacks is a free software which you can use to do star trails. because to kind of stacking multiple images. The smartphone apps, so I generally, my workflow is very simple. I use a DSLR and a compact camera. Both these cameras have Wi-Fi. And so I transfer my images from my camera directly to my phone. And I do a little bit of, a tuning, editing, a little bit of exposure change or a crop on my camera, on my phone itself. And that's it. That's all my workflow. But I'm not asking you to be restricted to that. All that I'm telling you that by this simple workflow, you can actually capture a lot of the sky. Advanced users will be doing panoramas. They can stitch, they can blend, and they can bring in a lot of Photoshop programs to give you stunning images, which is all there in the internet now. If I have time in the end, I will speak a little bit about the DSLR Astro Modified, but I think that is the next step. If you're done with the DSLR and the compact cameras, if you've mastered that, the next step will be the DSLR Astro Modified, which brings in the red range, and it is very good for astrophotography. So this is the most important slide of this entire talk, how to photograph the stars of the Milky Way. So you know that the star light is very faint. So essentially you have to take in as much light as possible. So in principle, what do? You have a wide open aperture, you have long timing, you have high ISO. Now each of these, there are also downsides of each of these. You have to understand the nuances. The aperture must be fully open. f2.8 or lower is better. Most kit lenses will be 3.5, but that's also good. But if you have a 2.5 lens, it's fine. Lower than 2.8, if you use 2 or 1.8, those lenses are quite expensive unless it's in a compact camera. And it's unlikely that an amateur will be having those lenses. These are mainly for the professionals. But it's not easy to use those lenses because there is aberration. There's something known as vignetting or something known as comma, COMA, comma, which happens in the edges of the frame, where the stars may look as if there is some kind of a trailing. It's not actually a trail, but it's actually some distortion, which happens at the edges. Now, you have to give a long shutter speed. Obviously, the problem of the long shutter speed here, in order for more light to come in, you have a wide open aperture and a longer shutter speed. But you are limited here because of the Earth's rotation. More the better, but you have to factor for the star movement because there will be star trailing. Because your camera is on Earth, which is moving, and therefore the star will show up as a trail. So there's a simple formula that you don't exceed 500 divided by the effective focal length in seconds. When I said effective focal length, I'm meaning the focal length of your lens factored the crop. There's a crop ratio of a crop sensor camera. If you're using a full frame, then your focal length of the lens stands. But if you're using a crop sensor, then it's like Canon or Nikon, they have a crop factor about 1.5, 1.6. So a 400 lens is actually, much more than that, is 560. And a 16 millimeter lens is probably 24. So you have to use that effective focal length in this calculation. So if you use a 16 mm lens on a full frame, then 30 seconds is your maximum. Otherwise, the stars will show a trail. And for a 400 mm lens, if you really want to focus or zoom into a few stars, then 1 second is your limit. But then there may be some trailing still in this formula. So some professionals, they go by 300 divided by the effective focal length. So your timing, all that I'm trying to say that your timing is limited here. So basically you're trying to balance between aperture and time and a high ISO. A high ISO we know gives rise to noise, but the ISO has been a game changer in the last few years. So after the DSLRs, you will not find a film more than 400 or an 800 ISO with great difficulty, even for a professional. And so you never saw good Milky Way photographs or Aurora photographs before the DSLRs came. Now, in the last 10 years, the internet is kind of full with all these fantastic pictures. And the ISO has been the real game changer. And the modern day cameras, ISO handling capacity is huge. And we can go up to 6,000 something. We can even use 12,000 something. So for this, don't worry about the noise. And you have to depend on the ISO. And 2,500 to 3,200 is a very good starting point. It changes because of the transparency of the sky. All the atmosphere may not be the same. There can be haze. So individually, you have to go to the location and then decide what is best for you. There's a little bit of tuning must be done on the field. If you want to take the Milky Way, you have to use a wide angle. Advanced users, in order to increase the pixel count, they take panorama, they take multiple factors like 3, 4, and maybe 2 rows of that, and they stitch on this software to give you high resolution, fantastic images. But that is the next step again if you really want to go into all that processing. So basically it's low light, and you have to have a wide open aperture, more time as much as your lens allows, and a high ISO to compensate for the other two. So this is the golden number. f2.8, 25 seconds, ISO 2500. But you see, if you look at, I'm going to show you all my images, the good, and I'll show you my bad images also, just to make you understand the principles of astrophotography. This is overall, you can say this image is stack sharp, but if you look at the edges here, you will see probably there's some trailing happening. So probably I gave 25 seconds, which is near limit of my lens, which is a 60 mm lens. Probably a 20-second exposure and a compensatory, maybe a ISO 3200 would have been better. You would have stopped trailing at the edges here. Now, focusing in the dark is not simple at all. You may feel that I am shooting at infinity. So I'll put my focus ring to one edge, to one and the end, or I'll look at my infinity mark and I'll just focus there. So that is not reliable. It is not in the dark. It doesn't work like that. Autofocus will not work in the dark. If you shoot into the night sky, the autofocus will just keep hunting. The stars will not. The camera wouldn't know the stars to be your object. So this has to be a manual focus. So how is it done? You can pre-focus in daytime in a very, very distant object, something in infinity, and you can fix the lens by a band which adheres to that. Or you can put a mark and use that in the night and do a focus lock of some kind. Or you can use live view while on the field. You use live view where it'll come on the LCD, and then by your fingers you expand the LCD and you zoom into one star at a distance. Now you begin with one focus, probably at infinity, and then you work from there. If you think that the star is not tack sharp, you can adjust your focus ring to bring it into real good sharpness. So this is the only way, and don't underestimate this. This is difficult, and it needs a bit of practice. So this is our Orion Kalpurush. You can see it in the winter sky. In fact, even now, if you look up, even in the Calcutta sky, if some nights are clear, you can see Kalpurush, the Orion. So this is the belt of the Orion. This is Betelgeuse, which is very soon going to be a supernova. Very soon. We have been saying that for some years now, but probably very soon, anytime. This is Rigel, and this is Sirius. Sirius is Lubthok. That's an Indian name. That's a dog star. And this is supposedly the most bright star in the night sky, other than Venus. Venus is a planet, of course. Venus is the most bright, but the next to that is Sirius. If you come to this side, this is the Hyades cluster, or the Taurus, and this is Aldebaran. Aldebaran is Rohini. The Rohini is the Indian name. Now you see here in this image, which I took at Iceland, you see the other light which is coming into this image. So this, on the left-hand side, lower down, you have the bus lights, and the distant lights are from the city. So even in a place like that, and we actually went out to shoot the night sky, to actually in search of the aurora, which was not happening that night. So we shot stars instead. So you see the amount of light pollution which is really coming in, even at that. Again, at the same place, I told you about the Orion, and this is the Hyades supercluster Rohini, and this is the Pleiades cluster. This is a naked eye cluster, and in Indian name is Kritika. And you see all these things in a row. Now here you can watch. If I go back to the previous image, the Sirius, Rigel, and Aldebaran, they form the lower arm of the winter hexagon. Now, if you use a compact camera, the problem with that, there are too many pixels there, and the pixel gets saturated very fast. So what happens, the big stars also, they don't stand out because they get lost in the sea of stars. So this is what is happening here. And here you see the Big Dipper. Big Dipper is Shoptor Shibondol, as we call it in Bengali. This is Saptarshi Mandal. You need to identify this because of it's easy to identify because of the distinctive shape. And this is one of the clusters which actually is used in navigation because it takes you to the pole star. So if this is the Saptarshi Mandal and this is the edge of the Big Dipper, if you connect these two and you extend that by about 4 times, this is the pole star. Now, when I was a child, I often looked up because I thought when I read in my school about the pole star, I thought it because it's North Star, it will be right on top of my head. And if you look there, and the brightest star there is going to be the pole star. It's far from that. We are in Calcutta. We have a latitude of 22 degrees, so it is more near the horizon. It's about 22 degrees up from the horizon. If you go to North Pole, it will be right up on your head. So it is important in navigation to understand what is this Big Dipper and how do you find the pole star from there. Sometimes when the stars are slightly out of focus, they are easier to identify. So it's practically the same picture, but here the stars are slightly out of focus. But you see the Big Dipper stands out, and so also is the pole star here, the Polaris. Now I happened to shoot the Big Dipper from the plane. So I was taking a flight to USA, and the flight was supposed to go near the pole, near the North Pole, and there are some polar flights, and I calculated and I took my seat accordingly so that on my left side I'll be close to the north side. And I wanted to shoot actually aurora from the sky. Sometimes it is possible to see and photograph that. So I had my compact camera and a small gorilla pod. I thought I'll try to do something, but I slept off, and then when I woke up, I suddenly, when I looked out of the window, it was a fantastic sight. The Big Dipper was just there. So I took out my compact camera and gave something. It's a little difficult and not a great photo, but I was quite pleased to shoot it from the plane. So how to photograph star trails? The star trails are pleasing to the eye. Now again, here the thing is a long exposure. As I told you that exceeding 500 by the focal length in seconds will show movement in the stars, but that will be a small movement that will not be visually pleasing. If you want to take visually pleasing photos, you will need much longer time, much longer time, sometimes exceeding an hour. So this gives you the trails, and they really look up. The problem here is that sensors may heat up if you want a single exposure. To avoid this, you have to take time-lapse multiple images, and you can stack up. Now, some cameras have the inbuilt star mode programs, and they can withstand all this, and they can really give you long exposures, and even some compact cameras. So this is about a 30-minute exposure, and you can see how the stars are trailing. And I included some foreground because without that, it seems to be completely out of context. You find a shooting star there at the top of this. This was just incidental. You cannot predict it. Here, taken from the city limits, the sky was slightly blue because it was quarter moon, the first quarter moon, and so it looks nice. And here there is some light, and you can see the movement of the leaves in wind because this is a long exposure. And there are the tracks of the aeroplanes they're crisscrossing because this was near the airport. Now, we don't see star trails. Probably a genius artist can imagine that. It's not possible for us humans to really do that, but probably Van Gogh did. This is a very eerie similarity between his Starry Night painting and my picture of West Yellowstone when I did the star trail. This is what we actually went for when we entered and we took the picture of the Milky Way. And there's quite an eerie similarity here. I don't know how Van Gogh imagined all that, but he did. It is pretty accurate here. If you see my picture, this is where the pole star is, because the pole star is relatively constant and everything else moves around that, because you can understand the Earth's rotation. As if you take an apple and you put a long needle in that, and if you rotate that, the Earth is rotating around that axis, and that axis goes through the Polaris. So the pole star doesn't move, but everything else will move in that. So the problem is here, the latitude was around 40, 46, 48 degree latitude. It is difficult to include the foreground because it is pretty high up. Now, if you want to take it only the pole star and see the star movement around that, you will lose the foreground unless you are doing it from low latitude areas like Calcutta, but you can't shoot it from here because there's so much light and atmospheric polluted. So this is again from West Yellowstone. This looks very futuristic, but there's no foreground here, so which is it gives an abstract feel to this particular image. But this is taken over about 50 minutes, and you can see some of the stars they have in colors because our night vision is not that good. The camera sensor is better. I'm going to come back to this point even later. You can see that some of the stars are showing colors over here. Again, taken from the city and some aeroplane trails, and the star trails and the aeroplane trails make a very futuristic picture as if from a science fiction film. So I now move on to the solar eclipses. I finished the first part of it now. Now I'm going to the second segment. And so what are the kinds of eclipses? You have the total solar eclipse, the partial eclipse, and the annular eclipse, which is a ring of fire, which is a kind of a partial eclipse where the moon doesn't cover the entire disk of the sun. So there's a rim of sun which is visible. All through the time of totality is called annularity here. A word of caution, never watch solar eclipse without proper glasses. You are likely to burn your retina because imagine the lens, imagine the magnifying glass that you play with, and I'm sure all of you have started burning paper through that. So that same thing will happen to your retina because your lens is going to burn up your retina because that lies on the focal point of that lens. Solar filters are required for photography also. You have to use a solar filter or some kind of a glass, and you need the solar filter, which is also required for photography. Otherwise, the same thing will happen to your sensor because sensor is lying on the focal plane of the lens of your camera. Your camera lens is going to burn the sensor unless you use a solar filter. So how does solar eclipse happen? Now, of course, eclipse doesn't, you can't watch it in the night. You watch it during the daytime where the sun is covered by the moon. So, and you're not seeing the moon, which means it happens on a new moon day. So the question comes that why not see it on every new moon? Because the moon's orbital plane is inclined to the ecliptic. Ecliptic is the name of the plane of the Earth's orbit around the sun. They are not exactly in the same plane. Otherwise, it would have happened on every new moon. It's inclined by about 5 degrees. So it only happens once in a while. So, the sun is fixed. The Earth is moving and the moon is moving. So the shadow cone is the umbral cone where it touches the Earth. It will be a circular shadow, but you're not in the circular shadow. So there's a path because both these things, the moon and the Earth, are moving. There is this path of eclipse which stretches across the Earth. And this is known as a shadow. But each eclipse, this is all well calculated. If you want to watch an eclipse, there's enough resources now which will tell you exactly where the path is going from, which end, where does it start, where does it end. So you see, if you're in the center of this path, if you're within this path, you'll be seeing the totality. Away from this path, you'll be seeing only a partial eclipse, which is hardly a spectacle. The real spectacle is within this. And if you're in the center line of eclipse, your totality time is going to be maximum. Now the edges are called graze zones. Graze as in the animals graze, it's the same spelling. The graze, if you're on a graze zone, so you'll be seeing the Bailey's beads and the diamond ring probably a little more, but your totality time will be less. You can work that out in your mind, how it happens. So in order to visualize a total solar eclipse, you will have to be within this line, within this band, and better if you are as close as possible to the middle line, which is the line, the center line. So I shot this partial solar eclipse in Calcutta back in 2009 from a rooftop. It was early in the morning. So early morning, you can look at the sun. At sunset, you can look at the sun. So there's no problem. And there was a cloud cover, so it was easy to really take it. And this was a maximum eclipse. It's a good sight for a first timer, but it is not as great. I mean, if you see a total solar eclipse once, there is nothing to match that. Clouds as a natural filter. This I took some during the last eclipse in 2020. There were clouds, so I could still picture that. I tried, there was cloudy sky, plus I used an ND filter. The ND filter is not the same as solar filter. ND filter is much less, is a neutral density filter. We use it for various purposes in photography. You can use an ND filter, but only an ND filter in a clear sky is not enough for photographing solar eclipses. Here I was experimenting and this is with cloudy sky plus an ND filter. Now, this is the solar eclipse picture I took in 2017 from Oregon. This was total solar eclipse, and I had to use a full solar filter because it was transparent. The atmosphere was transparent, and there was no haze, there was no cloud, so it was just this thing. And now you have to understand here that you have to work on the field, that what is your correct exposure. There's no way that you can predict that. You put a filter and you test out the sun. It depends on the latitude, it depends on the atmospheric haze. But once it is clear, once you have decided on a particular thing, and if there is no changing conditions in the atmosphere, then you can keep the exposure constant regardless of the size of the sun, because the luminosity of the sun remains the same, and therefore your exposure will also remain the same, unless the haze and the atmospheric transparency changes. So this is how it looks like. See, it is actually the moon. What happens really on a solar moon has actually risen earlier, and the moon is going across the path of the ecliptic. The moon's almost along the ecliptic. Sun rises later, and sun catches up with the moon because it's a little higher in speed, and then it touches there and it gradually increases. So as it goes on to the ecliptic, there are more and more of the sun's disk is eaten up by the moon. Now, I wanted to take a multiple exposure shot. I don't want to go into the computer. I try to keep away from the computer. I wanted to do a one shot but multiple exposure to show the eclipse progression ending in the totality. Now, planning is the key in this kind of things. What you want to have, there are 5 variables essentially. Your field of view of your lens, and a long lens will give you a very narrow field of view. So you have to understand how many suns, what is the diameter of the sun, what is the speed of the sun, and how many suns you'll be able to incorporate in your picture. What is the angle of the ecliptic, in which angle the whole thing is, the sun and the moon are kind of moving. What is the velocity along the ecliptic? The sun moves its own diameter, in one diameter, in about 2 minutes time. So you have to factor for all this, that how many suns in what time I have to get. And you must have a multiple exposure capacity of the camera. So you can know the time of totality and you can work backwards. And when it all comes together, you're so happy that I just took a picture of the LCD screen and I started sending to my friends after taking this picture. All the calculations came together. So this is that picture. Now, I knew this time. I knew the time this was going to happen at 10:20 in the morning. And I knew that the sun moves by one disk in about 2 minutes time. So I knew that I'll be able to fit in these many suns. So you start backwards. So you start here, 4 or 5 suns, and maybe I gave a gap 2.5, 3 minutes perhaps. So you back calculate it and I begin, and then everything comes together right there. Now you have to remember, if you're doing the totality time, the dimness, the sun is then not as bright. This is all by the solar filter, you see the color. But when the time of totality, the moon is completely covering the sun, and you're seeing the solar corona. The solar corona is not as bright as the photosphere, which is the disk of the sun. And therefore, this will not shine through the solar filter. You have to remember to remove the solar filter at the moment of totality. But before totality comes the first diamond ring. I was using a different camera. My son was using a different camera to capture this, because there's no way that I could take that shot along with this. So this was a second camera which my son was using. So this is the first diamond ring, and this is the totality. Now the brightness was a little less than the moon. You have to understand that you have to fix this. So you cannot, work so much. You have to know that what is the brightness likely to be, and you work around that. So this is the total solar eclipse. This is the best sight on Earth, I must say. This is, once you have seen this, there is nothing to match this. Second diamond ring, when the eclipse is kind of opening up, when the sun is passing through the moon's shadow from behind the moon, emerging again from behind the moon. So then the light will shine through the second diamond ring, and then the whole thing reverses. So that was total solar eclipse. The annular eclipse is no less amazing. So for both the total solar eclipse and the annular solar eclipse, you have these numbers. It is called the C1. C1 is with the first contact, and then it is progressing. This cloud, so I don't have to use the filter. But then close to the time, the cloud disappears, and I wanted that. So this is C2. when it touches the edge, when the moon almost is touching the edge and coming out into the disk. This is annularity. It's a perfect ring. So to take this, I had traveled to Nileshwaram. I could have been inside the band at any point, but to catch the perfect ring, I had to be on the center line of eclipse. So probably I was within 200 meters of that. So I had done that research, and we took a hotel close to that. And on that morning, I kind of positioned on as near as close to the line of the center line of eclipse, and which gives me this perfectly symmetrical picture. So then when it is ending, when it's going out again, you see the C3, the contact 3. These are the Bailey's beads. When you can see those valleys and the hills and there, and you see the spots, something is touching the edge. So those are the Bailey's beads. In a full solar eclipse, the light will be shining through, causing the diamond ring at this stage. So this is C4. Now this is a composite image. Obviously, this is not one image. And I took these pictures and put them all together. And you can see that this is where the last part, this is Grohan Mukti, as you say, that is just coming out of that eclipse. This is a composite image, but all done in my smartphone. So I'm coming to moon now. The moon is a very nice thing to practice on. So all budding astrophotographers should start from the moon. It's a different subject. So I will not go into that. I'll show you a few pictures of the lunar eclipse, and I'll just explain how the lunar eclipse happens. In lunar eclipse, it's the other way around. The Earth is now coming between the sun and the moon. So the Earth shadow, the umbra and the penumbra, the umbral cone, and when the moon gets into the umbral cone, the penumbral shadow is very faint. You will not be able to discern it by the naked eye, or maybe in the late stages only. So it is not very spectacular. But the real lunar eclipse is when it enters the umbral cone. Now what happens with the umbral cone? The blue light of the sky is scattered. It doesn't reach there. But in the shadow, the red light can reach. And the red light, so when the moon enters this, it becomes red. When at the time of totality, the moon becomes red. It is also therefore known as the blood moon. So there is widely variable luminosity depending on the atmospheric haze, light pollution, and the stage of eclipse. So it is impossible to give you a ballpark figure with which you start. You have to work on the field, what is working on that, and you have to constantly change your exposure during a lunar eclipse because the luminosity changes like anything. So this is in Calcutta, and my pictures are of very poor quality, but that is because of this huge noise. And why the noise? Because it was barely discernible. It is hardly visible because of the atmospheric haze, and it was pretty low down. It was early in the evening. Later in the evening could have given me a better picture when the moon would have risen above the low atmosphere. The low atmosphere is the worst. And I was using ISOs of 12,800. So obviously the pictures are not of great quality, but I'm happy to capture that. You see the blood moon here. And here again, Grohan Mukti, this is coming out of it. It's now coming out of it. The moon is shining through, and here is the earth shadow, and it is just coming out of it. This I took from my rooftop after going back home. And you see, this is the penumbral part. So the top part of the moon is a little more dark than the lower part because there's still the penumbral shadow going on. So these are the shadows of the moon. I'll next go to the Aurora Borealis. So this is another great spectacle, the north lights, the northern lights. As you say, why it happens? It happens because you see the sunspot activity. Whenever there's a sunspot activity, it is the predecessor to the solar flare. The solar flare, the solar wind, which is basically charged particles, protons and a few other particles, they start their journey towards the Earth. In about 1.5 to 2 days' time, they will react with the magnetosphere of the Earth. Now, the Earth, there's a magnetosphere. Why that happens? There's a magnetic field. Why that happens? The Earth's core, the outer core, has got iron, has got nickel. So when the Earth rotates, there's kind of change there, and because of the rotating thing, there's electricity generated. And it's known as the Dynamo Effect, as you read in physics. And so it gives kind of a polarity, the magnetic polarity towards the poles here. So the solar wind, the particles react with and they're kind of brought in towards the poles, the north and the south, Aurora Australis, which we can see over Antarctica and maybe in the southern part of Australia, and mostly in the Arctic zones when they interact with the atmospheric gases and they'll light up the gases because of the reaction. And the atmospheric gases give color. Nitrogen gives a color, oxygen gives another color, mostly green and red. So this is the first one. My first aurora viewing is a bad picture, but I took it from a ship. So this was in Norway, and it was announced in the night there's an aurora visible. So we ran to the deck. I had only my compact camera. I put it on a gorilla pod and wrapped that gorilla pod around the bar, around the handle of the deck. And again, the principles are the same. Aperture as much as possible, wide open lens, ISO 3200. But you have to understand, you have to factor for two things. Firstly, the ship was moving, so you cannot give too much of long exposure. Secondly, if you give too long an exposure here, so this requires even shorter exposure than when you do the Milky Way or the stars, because you lose the structure of the aurora. If you give it longer, it will be one green awash sky. It is kind of a homogeneous wash. It will not show you the structure of the sky. So shorter exposures again. This is 5 seconds. This is in Norway. This is in Sweden, Finland border. We were right on the snow, sitting on the snow, -10, -15 degree. My main camera froze up. So this is by a compact camera. But I still took it. I'm still happy. It's not a great picture, but I'm still happy taking it. f1.8, ISO 1600, 5 seconds. Now, camera sensors are more sensitive than the retina. The light vision is by rods. Rods are weak sensors. In daytime, you see color. That is the cone. In nighttime, you don't see color because our rods are extremely weak sensors. The camera sensors are more sensitive. Whenever you will see an aurora picture, you'll see them in great, glorious colors, like green. In fact, the camera sees it like that. This is straight from the camera. I haven't done anything. It shows bright green. This one, I actually downplayed the color in my phone to approximate what the actual eye sees. The actual eye sees a much less intense color than what the camera sees. So this is on the right panel. You see what the aurora will look like. And the camera will show a much brighter, a much more intensely green color thing. So that is true. If what you see on the internet, most things will be looking at one shade, perhaps less. This is again a similar picture. This is how the aurora structure. This passes like curtains over the sky. And even that aurora is coloring the snow here. There's a uniform snow there. And it's kind of coloring, reflecting off the snow. You need to be in full Arctic suits. It's -15, -20, and your equipment can freeze up. In fact, my main camera did. So all these are taken by the compact camera. So start trail with aurora. I even tried that for about 25, 30 minutes, I think, sitting in the bus and putting it there and sitting in the bus in order to sort of, whatever it takes, I'll be happy. There wasn't much aurora activity excepting one streak. And you see that there are gaps in between the star trails. That's when the cloud was coming. And so this is about maybe 30 minutes, and I was happy to get this star trail along with aurora. Sometimes the aurora starts as a wisp, a thin wisp in the sky. And it gradually increases after that and takes various shape. And then sometimes there's an aurora storm. I haven't seen that, but lucky ones have seen that. And it really goes over one side to another side, one horizon to another side. And then aurora, there's a crown formation right at the top. Here you can see the Big Dipper, the edge of the Big Dipper, our Shaktochi Mondol. And the one way of knowing this star is Arcturus. In Indian name is Shati Nakshatra. So if you extend the tail of the Big Dipper, if you extend the other side, you read Polaris. If you extend the tail of the Big Dipper, you go to Arcturus. This is just by the way, I thought it would be of interest. Now look at the colors in this photo. The blue is of the sky. It's not intense dark because there was moon. There was a quarter moon, and the quarter moon is lighting up the clouds here on the right-hand side. Here's aurora streak, and there's an orange glow is from a distant town. So the aurora is getting stronger now, getting stronger. Sometimes it forms a corona. And this I've used a fisheye lens from one horizon to another horizon, 180-degree view using a fisheye lens. And it's a very strong aurora. But then, of course, there's a camera view. In eye, it will be looking slightly less green than this. How do you identify planets? Well, they don't blink. It's easier. There's another way. You must know where to look. If you're in the northern hemisphere and you're looking in the southern sky to look for planets, you'll not see it there. I mean, like if you're if you look in the northern sky, you're not going to find the planets. If you look in the eastern sky, you will not find it there, excepting maybe the Mars and Venus. You have to look along the ecliptic. You look at the sun's movement during the day. You look at the moon's movement during the night. You know which line they're passing through. So that's the ecliptic. And these planets will all be, because they're all in the more or less in the same plane, they'll all be in the ecliptic. Look along the ecliptic and you will find the planets. Mercury and Venus are inside planets, inner planets. So they are, you can see them either during sunrise or, close to sunrise and sunset, either in the west or where on the east. Otherwise, you will not find them. Venus is clearly the most bright object in the sky. If you, the western side, in the evening, if you look, the brightest object on the western side is Venus. Mars is yellowish. It depends on the time of the year. Sometimes Mars is really strong, like last year Mars was close to Earth and it was really strong. Jupiter is generally very bright. Saturn is less so. You can photograph by your camera. Now this is again bad pictures, but just to show you that you can photograph the Jupiter. I am showing the moon because that day, in order to know the Jupiter, you have to look close to the moon. Look at the angle. The moon and Jupiter, they're along the ecliptic, more or less. And Jupiter's moon, imagine that Galileo saw that 500 years back by his home telescope. These are the Galilean moons. I had a 400 mm lens and there was a hazy sky, so I gave a long exposure. I gave a 5-second exposure. So everything moved. The Jupiter moved and even the moons moved. But you see, again, they are all moving along the ecliptic. So this is parallel to this line here. So Jupiter and the planets are kind of all along the ecliptic, and so are the Jupiter's moons. And if you have a 400 lens, you can easily photograph this. Sky has to be clear, of course. Moon and Venus conjunction. This year is full of conjunctions. So interested persons can really look up, and all the dates are there in internet now. You can look up and see all the planets together. Mars close call, October 2020. It doesn't show as yellow as it is into the naked eye here. I took long exposure because I thought it is going to be better, more spectacular. There's a plane track. See here, the Mars is moving along the ecliptic. It's a straight line. And look at the star trails around that. Star trails are either in both ways. They're kind of curving. They're kind of curving on the side. But along the ecliptic, Mars is pretty straight. So this is back in BITM. 19th of December was the Jupiter-Saturn conjunction. And we took it from the roof. The sky was very, very, very hazy. And you see both the planets together. You could just barely make out there. And BITM was holding the show for general people. I also came as a general person, but then I went up and I introduced myself that I'm interested in this. So help me taking all these photographs. The next day, I think in the same night, I took it from another spot. So here is by a long lens, and they are close together. They don't look very spectacular unless there's some foreground there. So I tried something else. I took a long exposure. So there were no other stars. It was so hazy. So this is a wide open view and a long exposure of the Saturn and the Jupiter conjunction. But in this compressed view, and because there is no other star, the Jupiter and Saturn, they are all looked together. You cannot identify them as separate here. So that line you see is the Jupiter and Saturn together. Now this was perhaps the star of Bethlehem. And this was the guiding star for the Magi, and which led them to Jesus' birthplace. Probably one of the combinations that was possible. So Jupiter and Saturn, there are other views about it, but most people believe that it was Jupiter and Saturn at the time of Jesus' birth. So in this picture you see, everything comes together. There is mythology, there is history, there's religion, there's science, and there is art. Everything comes together. So astrophotography, there's also an art and science, sometimes even philosophy also. So I end with the miscellaneous info, which you might be benefited from that. What are the dark sky locations in India? Number one is Ladakh. Nubra Valley is fantastic. Traveling is a bit difficult, but you have to do that. If you're interested, you must do that. Hanle, there's a fantastic observatory there. And the Pangong Solo Lake, also Somoredi. Now you have to harden it out. There's no way out. The temperatures can be really low and windy, and your staying will not be comfortable. but the view that you will get is very, very rewarding. And I will ask everyone to go there. Andaman, Neel Island, Ran of Kutch, and I'm told that Uttarakhand, there are many regions where I do this. If you're interested in photography and if you're also interested in star and all, download this app called PhotoPills. This is a wonderful resource. They're very extremely detailed and very nerdy, I must say, very, very nerdy. Beyond a point, it is very, very difficult to go into all those calculations of that, but it is a fantastic resource. I really will ask everyone to download PhotoPills and familiarize yourself with all that they're saying. Smartphones will be gradually better. iPhone, Samsung are very good, fairly good night capacities, but not to the extent that you can do astrophotography greatly. I am told that Oppo and Oppo, the Pro modes, the Reno Pro, I forget the name, they have fantastic nightscape capabilities. Also the astrophotography capability, and Huawei also. So I think next 5 years' time is going to change the game completely. You will be able to do a lot in the smartphone, and that will increase the awareness, and people will be naturally drawn to the sky, and which is going to be a good thing. Now, upcoming, there's going to be a total lunar eclipse on 16th of May and 18th and 8th of November, but it's not visible from India. It's very well visible from US, first from the East Coast and then from the West Coast. And if you have a friend in US, you should tell them. There's a partial solar eclipse on 25th of October in northern part of India, but unfortunately in Calcutta, we will see much, much less, probably not much at the time of sunset, just a little touch there. But in Delhi, the magnitude is going to be 0.5. It's not a great spectacle, but it is a good one nevertheless. I think people who are interested should go north and then try to see this. Thank you very much. I'll take questions, and I have enough time, and I'm not tired by this. Yeah, I'll answer all your questions.
A view of the celestial spectacles keeps us all our overworked, increasingly compartmentalized lives in perspective. As astronomer Neil deGrasse Tyson put it, when you look at the night sky, you realize how small we are within the cosmos. It's kind of resetting of your ego. To deny yourself that state of mind, either willingly or unwittingly, is not to live at all to the full extent of what it is to be human. Thank you, Dr. Dutta, for sharing your experience and inspiring us to revive our ancient connection with the heavens. Now, most of us will never get a chance to step off the earth. So looking up, calculating, capturing, processing, and hopefully sharing is the next best thing for me. But I'm from Kolkata, and here in the heart of the city, you can see the moon, a couple of stars. More often than not, they turn out to be airplanes when they land. So what should my ideal astrophotography targets here be?
So from Calcutta, you have to be. So firstly, you can see the phases of moon, which is itself a very good subject for photography. And moon photography. Moon is a good thing to practice on, the phases of moon. Lunar eclipse will be common. I'm sure if you don't see it this year, lunar eclipses are fairly common, so you should be able to see lunar eclipse. You can see a little bit of solar eclipse in this one towards the sunset, and you can see the stars and you can see planets and you can see the conjunctions. They are visible from everywhere, and you will be able to see I would say the constellations when the sky is clear.
Thank you, sir. And we have our chat boxes full of laudatory messages that we have for your lecture, your wonderful pictures, your Van Gogh analogy, your polar Ursa Major snaps, and the eclipse images. We have people praising you, and we have people inviting you over, especially to North Bengal. I'm seeing a lot of messages because of the clear skies over there. And yes, there's also a suggestion for Oppo to include in your suggested list of phones to go with it. And
I wrote Oppo.
there's one question from Mr. Deepak Shaw. He says, since we are close to the equator, how can one take fine captures of stargazing quality images from Kolkata and West Bengal regions, and what configurations does the DSLR need to have in particular?
Your standard DSLR and a kit lens is also good. If you have a wide angle lens like 1635, it is also, or I think 15 something for Nikon, they are extremely good. The 2.8 lenses are extremely good. But even your kit lenses are not bad. Your kit lenses can really tell you everything. Now, the problem is the city. The problem is the city lights and the atmospheric pollution. It's not a transparent atmosphere. Even if you have a dark location, the atmospheric haze stops a lot of viewing. The same with telescopes also. Even if you put in a telescope, you may not be able to see anything much. So it is atmospheric haze, which is the real deterrent, I would say. Other than that, what I mentioned to Aditi, the same things you can see. They see the constellations, a few of the constellations, like the night sky. Orion is always there. Orion you can always see.
Right, sir. And I think you have already answered this, but still we have a question from Shuchanda Shet Roy. She wants to know, when will there be a solar eclipse that can be visible from India within a short span of time?
Mentioned in the last slide about the partial solar eclipse, which is going to be visible in October from northern India, but is going to be a magnitude of 0.5 only, which means half the sun will be covered, not any more than that. If you go north up in Kazakhstan, it will be close to 0.8, 0.9. It's not a total solar eclipse this year. I don't think India is going to see a total solar eclipse in any time soon. In 2023 and 24, there are eclipses in US, Mexico, and also touching Australia on the western side of Australia, maybe in 2023. So there is all this is available in the, there are many sites. You can go to the NASA site. There's a site called eclipse.com and many others. And there's a site called Time and Date. So you just go there and you will find all the upcoming eclipses. Unfortunately, I always look every few days. I am also checking when is the next one. So there's unfortunately nothing much in India in terms of solar eclipse. Not total solar eclipse, certainly.
There are two people who want your comments on meteorite showers. They are Shudipta Das and Himanshu Nagar. They want to know about meteorite showers.
There is a certain time period for each of these meteorite showers, and this is a wonderful thing to photograph. In fact, my own interest, let me tell you a nice story. So my interest in this came because in a newspaper, this meteorite shower, I read an article. This is probably in 1989. So I used to work in another hospital in that time, probably in the mid 90s, not late. And I went back in the hospital. With a great difficulty, I found out an 800 ISO film. And I had a small film camera, the usual film camera, DSLR. So I put that film there, and I thought I'm going to, it is an 800 ISO film. And so I was up there. I went to the roof of the hospital in the middle of the night, and I sat for about 3-4 hours in the dead of the night, hoping that there were a lot of meteors, expecting that. It doesn't happen like that. You really have to go to a dark sky location in order to, it will not happen in the city. One stray meteor you can see, but you will not be able to capture that. So way to see is you have to go to a dark sky location, carry a blanket with you, put the blanket on the floor or on the grass, and just lie down and watch the sky with an indefinite time span. On that particular night when the meteor shower is going to happen, you just watch. You be there. You have to know where it is happening, and just watch it. And you have to train your camera also like that. Put on the time lapse kind of a mode or this multiple shot mode, by an intervalometer, and the camera will be taking continuous pictures of the sky. That is the only way that you can take a photograph of the meteor shower.
Right, sir. And I think the last question from Sanjoli, the question is, will the people of Calcutta ever get to see a full solar eclipse?
Well, we saw that in 1996. There was a spectacular diamond ring. I think many of us remember that. And we saw it from our roofs. Of course, we did. And it can come back. I haven't checked whether what will happen in the next 30, 40 years, but it's not going to happen in the next 5 or 10 years. That much I'm sure. But I haven't checked beyond that. You might still have it. In fact, tonight you can just check it. It is just one click away from you. After the talk finishes, you just go through the calendar. And you will know what is going to happen in the next 100 years. So
there's one question from Mr. Ashok Kumar Bhagat, and he wants to know about Jupiter, the gas giant.
So I am not an astronomer, neither am a photographer. You have to ask me something more specific about that. About if it's a photography angle, then I may be able to take it. If it's an astronomy angle, I will not be able to take it. So what exactly about Jupiter? Tell me.
So, Mr. Bhagat, could you please specify your exact query so that we can put it to the speaker? And meanwhile, we have another question. So, is the solar eclipse ever possible in Kolkata, in the main city? This is from Reena Shaw.
Yes, it is of course possible, but I think I answered the question already. It happened in 1996, and I don't know when the next one in Kolkata will be available. But it is. You can check that out. There are internet resources which will give you the full calendar for the next 100 years, perhaps.
So, then shall we call it a day then? So thank you, students, teachers, friends, and patrons of BITM who could make it to this live session today. As part of our celebrations leading up to the National Science Day 2022, we are due to cover a storyline from coal to renewable energy sources in our next YouTube live meet on Monday. Do join us here again. Sincere thanks to the entire behind-the-scenes team for enabling such virtual meets and keeping us all connected. In a way, you are our guiding star. So until we meet again, goodbye and good luck.
Yes, Doctor. The lecture was fantastic. Your lecture was fantastic.
It was okay?
Yes.